fusing atoms. Some of the world's leading researchers have spent decades and millions of dollars trying to achieve this in the laboratory. Scientists in Utah tonight believe they have taken a big step forward in a little test tube. CBS News correspondent John Blackstone begins our coverage of what may have been achieved and what it may mean to you.
If what is happening in these test tubes is indeed controlled nuclear fusion, as the scientists who set up this experiment believe, then this laboratory may one day be known as the birthplace of cheap, clean, and abundant energy. The two scientists who believe they have found a practical method of nuclear fusion say when they started, the chances of success seemed to be 1 in a billion.
Stan and I thought this experiment was so stupid that we financed it ourselves.
The scientists were attempting for the first time to accomplish nuclear fusion at room temperature. Until now, the fusing of two atoms to release energy required so much heat that the experiments consume more energy than they produce. But the scientists working in Utah say in their experiments at room temperature, they have been producing more energy than they use.
Much more energy is coming out than we're putting in.
The raw materials used in the experiment are common metals and seawater. If the experiment can be reproduced on a larger scale, seawater could replace coal, oil, and uranium.
A cubic foot of seawater is equivalent to 10 tons of coal.
The experimental findings have not yet been published for review by other scientists, but Edward Teller, the physicist who played a key role in the development of the hydrogen bomb, may have to revise his prediction that the practical use of fusion energy is 40 years away.
It seems that controlled fusion works. It did not in free space, but in the confinement of a metal in which the hydrogen nuclei can move freely. It appears that the reaction does go forward and there may be a real breakthrough.
The scientists in Utah say they have tried hard to prove that their experiments are wrong. Now, other scientists will begin to study if this is the breakthrough it seems to be. John Blackstone, CBS News, Salt Lake City.
Science has long known how to make atoms fuse at extraordinarily high temperatures. But the problem for decades has been to control such fusion and put it to practical use. Could today's discovery be that first step?
I'm very excited that we've found a new fundamental process that's never been observed before for how fusion might be made. On the other hand, it's clear that this process is very small scale.
Yes, it is sort of a surprise to many people in the fusion community, and we wait with interest to hear the details of what's been done.
With great interest because of the eventual promise of fusion energy. The raw material, deuterium, is found in water, a fuel supply that would last as long as Earth is around to need it. Unlike today's nuclear plants, a fusion energy plant would not create radioactive waste. The process also cannot rage out of control, as it did, for example, at Chernobyl, since atoms are being fused, not split apart. And finally, fusion would avoid atmospheric pollution.
It would eliminate the problems of the greenhouse effect and acid rain type problems. So in many ways, it's an ideal energy source for the long term.
The Department of Energy is spending over $500 million on fusion projects, none of which currently involves the new technique. But a spokesman said today that funding for this research will start in May. Susan Spencer, CBS News, Washington.